All right, let's take a look at this. So a 0.980 gram object with a charge of 0.78 microcoulombs is positive, suspended against gravity between two horizontal plates. Let's draw a picture of that. There it is, right? And they're 3.8 centimeters. So this distance, this delta R, is 0.0380 meters, right? And it is, oh, okay, so we know the mass, right? So here's this thing, and it's got a positive charge on it, right? So then it says, which plate is the positive plate? Well, we want an electrical force upward on this thing, right? Because what's happening here is that the electrical force, EQ, is up, force of gravity is down, which is mg, right? And ultimately, we're going to say EQ equals mg, right? So this is the electrical force, and this comes from what? Electric field is equal to force divided by charge. That's in the data packet. And this comes from G is equal to force divided by mass. Okay, that's how it's written in the data packet. Okay, so in order to have an upward force on a positive charge, we put the positives underneath it. Right, so this thing is, these are attached to some voltage source, and we just do that, right? All right. So, what voltage does this require? Okay, so let's just fill in what we know. Our mass is here, right? So 0.980 times 10 to the minus third, right? Because it's grams and you want kilograms, so you got to divide by 1,000. 9.81 newtons per kilogram. Oh, we've got the charge, right? 0.78 times 10 to the minus sixth. And then I guess we'll solve for E. We can solve for E, right? Okay, so 0.98 E minus 3 times 9.81 divided by 0.78 E minus 6. Wow, that's a big electric field. Electric field is 12,325.38. That's newtons per coulomb, or by the way, it's volts per meter are the same thing, right? So now we have the electric field. Now we're going to use this formula, which is electric field is, right, I always ignore, well, I don't always ignore that minus sign, but in this case, I don't really need any direction from this. I know where the positive charges are and everything like that. But I am going to use it to figure out the voltage. Okay, so let's plug this in. So 12 is equal to the voltage, which we're trying to find, right? The change in voltage over the distance is 0.0380. All right, so I guess I just multiply that by that. So times 0.038. And I get 468. So the change in voltage from the top to the bottom is 468 volts or joules per coulomb. Either one is correct. But with electric potential, we've got a special word for that. It's volts. Hey, we got it. The bottom is positive. I think we answered everything.